Welcome to Mobad Education YouTube channel. This is Jyoti CH PGT Chemistry TSMS Kalwala.
Good morning students. Today we will go for the chemistry chapter in 10th class, which is called as metallurgy. Okay, and metal. Have you heard this term? Yes, you heard the term metal in your 8th class, and you also learned some physical properties of metal in your 8th class. So can you give some examples where you observe metals in your daily life? Yes, you observe copper, iron, aluminium, silver, gold, platinum and few other metals in every walk of your life. Like in electrical wires, kitchenwares and jewelry. Where from these metals are obtained? Okay, these metals are obtained from Earth's crust. Earth has parts like crust, mantle and core. You study in your social studies. In that Earth's crust, you will obtain metals. Okay, and also metals are also available in the form of soluble salts in sea waters. NaCl and MgCl2, sodium chloride and magnesium chloride are soluble salts available in the sea water. So these are in the combined form. Not only these, few other metals which are more reactive, are not available in the native or free state. They react with oxygen present in the air, carbonates, bicarbonates, sulfates, sulfides and chlorides present in the atmosphere and forms a combined or compound forms. This combined or compound forms of most of the metals are called minerals. But few metals which are least reactive are mostly present in the native form or free state, not in the combined form. And least reactive metals, some you have to remember, Nana: mercury, gold, silver and platinum. Okay, so but in order to extract a metal from these minerals, you have to take two conditions. First, we have to get a high percentage of metal and with low economy, that means with low cost. Only that mineral is to be selected to extract the metal. Okay, so that minerals which give high percentage of metal with low economy or low cost are called ores. So all minerals are not useful to extract metals. Only few minerals are useful to extract metal with high percentage and low economy are called ores. And this process of extraction of metal from the ore is called metallurgy. So all minerals are not ores. Few minerals which give high percentage of metal with low economy are called ores. But all ores are minerals. You have to remember this point. After this, you go through the ore formulas in table 1 in page number 238. After thoroughly following or practicing the formulas, you classify the ore formulas into oxides, sulfides, chlorides, carbonates and sulfates. Okay, and while classifying them, you have to remember at the end of the formula, if it is O or O2 or O3 or O4, then those ores are called oxides. Then if at the end of the word there is S or S2 or S3 or S4 like that, you confirm them as sulfides. If at the end of the formula you find Cl or Cl2 or Cl3, you confirm that ore formulas as chlorides. If at the end of the formula if there is CO3, then you confirm that ores as carbonates. If at the end of the formula there is SO4, then those ores are classified as sulfates. So those for ores means bauxite and its formula is Al2O3 2H2O, and pyrolusite at the end O2 is there, MnO2, and hematite Fe2O3, and magnetite Fe3O4, and zincite ZnO. So all these are at the end O2, O3, O4 are present are called oxides. And you take copper, iron, pyrites, CuFeS2, S2 is present. So these are sulfides. Zinc blend, finally S is present. So these are sulfides. Cinnabar, HGS sulfide, mercuric sulfide. Galena, PBS, lead sulfide. All these are sulfide ores. And if you go for chlorides, you see here Han silver is present in the table 1, AgCl. So this is a chloride. And rock salt, NaCl, this is also a chloride. And carnallite, KCl, MgCl2 and 6H2O. This is also chloride. And magnesite, which is a carbonate, which is called MgCO3, its formula is. Limestone, its formula is CaCO3. These two are carbonates. And sulfates are Epsom salt and its formula is MgSO4 and 7H2O. And gypsum formula is CaSO4 2H2O. And metal present in these ores is aluminium. Metal present in these ores is manganese. Here iron, and here zinc. And here copper, here zinc, here mercury, here lead. And metal present here is silver, sodium, potassium and magnesium. Here it is magnesium, here it is calcium. A metal present in Epsom salt is magnesium. Metal present in gypsum is calcium. This is how you have to classify the ores into oxides, sulfides, chlorides, carbonates and sulfates. And you have to identify the metal present in the ore by thoroughly practicing the table 1, and you have to fill table 2 in 239 page. As I already explained you, few metals are with high reactivity and few are with low reactivity, which are found in native or free state in nature. If you arrange the metals in the decreasing order of their reactivity, then that series is called activity series, which is present in the table 4 in page number 242. And you have to exactly remember this order, which is very important in the exam point of view, Nana. First one is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, platinum and gold. And the first topmost 5 are classified as high reactive metals. And the zinc, iron, lead, copper are treated as moderately or medium active metals. Mercury, silver, platinum, gold are with least reactivity, which are found in the free state. This may come in the MCQs. First, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, copper. The exact order you have to remember. Then we'll go to the actual topic. Extraction of metal from the ore is called metallurgy. And this metallurgical process actually involves 3 steps. First one is concentration or dressing or enrichment or removal of gangue particles from ore. That means ore minus gangue particles. And what are the gangue particles? Metal is obtained in the combined form as ore. These ores are obtained from its crust. Generally, it is mixed with the soil and sand impurities. The soil and sand impurities are called gangue particles. So, in order to remove these gangue particles from ore is called concentration or dressing or enrichment or removing gangue particles. And the second step is extraction of crude metal. And third step is refining or purification of crude metal. So, we'll go in detail about the first step in the metallurgical process, concentration or dressing of ore. The concentration or dressing of ore will remove gangue particles, that means sand or clay particles from the ore. Okay, so depending upon the physical properties of ore and gangue particles, there are different types of methods in this process. So first one is hand picking. We'll go for the hand picking process when there is a difference in the size and color of ore or gangue particles. We'll go for hand picking. That means we'll separate the ore from gangue just by hands. Okay, and the second process is called hydraulic washing or gravity separation. And this hydraulic washing is mainly based on the density difference of ore and gangue particles. One of it is more denser, another one is high denser. If ore is more denser and gangue particle is lightly denser, then we'll go for the hydraulic washing. So in this hydraulic washing, on a slopy surface, the powder ore is made to fall through a hopper. Then from the sidewise, the water will be pumped slowly. Then the flowing water from these ore takes away the light density gangue particles, and the high density ore particles are grasped here in these corners. Okay, this is how the ore and gangue particles are separated by using hydraulic washing. And the third one is the froth flotation. This froth flotation process is mainly used for sulfide ores, specially used for sulfide ores. This froth flotation process is mainly based on the wetting property. These sulfide ores have non-wetting property in water, and these sulfide ores are also lightweight. So based on these properties, we'll go for the froth flotation process. In this process, take a beaker and place a crushed ore with gangue particles or impurities at the bottom of this beaker. Then add water and pine oil. Then a pipe is fixed like this in order to blow the compressed air. When we blow the compressed air into this pipe, the air pressure creates some bubbles, and this soap bubbles takes away the non-wetting sulfide ores in the form of froth to the top side of this beaker. Then this froth is collected. Froth means nuraga. Okay, so this froth is collected and carefully washed in order to get the gangue-free sulfide ore particles. The fourth method is magnetic separation. This magnetic separation is based on the magnetic properties of ore and gangue particles. If ore is magnetic and gangue particles are non-magnetic, or if it is non-magnetic and gangue particles are magnetic, then we'll go for the magnetic separation. For example, think ore as a magnetic material. Then powdered ore is placed on this, sent onto this conveyor belt through a hopper. Then this belt moves on these two wheels, one of which is non-magnetic wheel and the other one is a magnetic wheel. So the ore as passes through this belt, non-magnetic gangue particles, that means sand and clay particles, which are non-magnetic, so they are not attracted towards the wheel, so fall down here, collected in a beaker, and ore particles which are magnetic or stick over to this magnet and falls here, and these are collected in another beaker, which is the ore free from gangue particles. And this process is mainly used for iron ores like hematite and magnetite, because iron has a magnetic nature. For sulfide ores, we'll go for froth flotation process, and for iron ores, we'll go for the magnetic separation process.